Okay. Um, Today, all of the math teachers are gone, so I'm recording your lesson. It shouldn't take too long to watch, and then you'll have the rest of the time to work on the homework. So today is 6.2, and we're still going to be dealing with ratios and proportions, um, and we're just going to keep working with those. Um, so the first two things I have here are some properties that you can use whenever you're dealing with a proportion. And again, a proportion is when you have a fraction equal to a fraction. And so there's different ways you can set them up. One person might set it up one way, another person might set it up another way, and it's good to know that those two ways are equivalent. They're the same. You'd get the same result. So here's the first property. We have A over B equals C over D. And then all of a sudden, this ends up equaling the same thing as B over A equals D over C. And I tried to color code it for you, but here's kind of another way of looking at it. You see how the blues are on top and now the blues are on the bottom? And the reds are on the bottom and now the reds are on top? Well, all that's happened is that we've flip-flopped it. So A was on top, B was on bottom. Now B's on top, A's on bottom. C was on top, D was on the bottom. Now D is on the top, C is on the bottom. So they flipped. Each fraction flipped. Flip this fraction and you have B over A. Flip this fraction and you have D over C. And let me just show you with numbers, because sometimes when you're looking at numbers, it makes just a little bit more sense. So let's assign some values to these four, but we have to make sure that whatever fraction we come up with, they have to actually equal one another. So let's say that A was 4 and that B is 2. Okay, so I have to know that, okay, that 4 divided by 2 is 2. So whatever numbers I choose for this, they have to also divide to equal 2. So I'm going to do like 6 over 3, because that also divides to equal 2. So that's a true statement. 4 divided by 2 is 2. 6 divided by 3 is 2. It works out that 2 equals 2. It's equivalent. Okay, well, according to this property, I should be able to flip the fractions, and they should still equal one another. So now I'm going to flip, and the 2 is going to go on top, and the 4 is going to go on the bottom. And then I'm going to flip, and the 3 is going to go on top, and the 6 is on the bottom. And if you reduce these two fractions, 2 divided by 4 reduces down to 1/2. And same thing here, 3 divided by 6 also reduces down to 1/2. So they are still equal. So I can set up a proportion this way, or I could set it up this way, and they'll still equal one another. They'll still work. So that's the reciprocal property. Okay, then the next property, I also tried to kind of color code it. So look at what happens to the blues. They were on the top. Yeah, maybe I'll highlight it. The blues were on the top, and now they go vertically. So like they went horizontally, now they go vertically. Okay, and look at these on the bottom. They go horizontally, now they go vertically. So that would be another way to set up a proportion. So let's use the same numbers, and you'll see that it works. So again, I'm going to use the same numbers. 4 over 2 equals 6 over 3. Okay, now, but according to this property, 4 and 6 are going to be written vertically. 4 divided by 6. And 2 and 3 are going to be written vertically. 2 divided by 3. And the question is, are those equal? Well, 4 divided by 6 reduces down to 2 over 3. So yeah, they are equal. Same thing over here. 4 divided by 2, again, was 2, and 6 divided by 3 was 2, so they are equal. Okay? So I guess what you really need to know from this page is there's more than one way to set up a proportion. And so let's say if Taylor does it one way, Marley might do it another way, Tenley might do it another way, you know, so they can all do it different ways, but it'll still work. Okay? All right, next page. So now we're going to tell whether the statement's true or false. So we try to use the properties from the last page. Well, I'm noticing that P and R went horizontally before, and now they're going vertically. So let's take a look at what would happen if we did 6 and 10, if we made 6 and 10 go vertically. Okay, so if I had a 6 here and a 10 here, going vertically. Well, 6 over 10, if I divide the top and the bottom by 2, 6 divided by 2 is 3, and 10 divided by 2 is 5. So it does work. It does work. Okay, this one over here. Well, S and 15 don't go vertical. 10 and T don't go vertical. So it's not that same property. What if I flip them? Well, if I flipped this, 10 would go on the top and S would go on the bottom, and that's not happening. Same thing here. If I flip this, T would go on the top, 15 would go on the bottom. That's not happening. So I don't think this is working, but it might help to plug in some numbers. Oh, by the way, this one was true. Back to down here. I kind of don't think it's going to work, but let's verify using some numbers. Let's just, you can make them up, okay? I'm going to make S30. So 30 divided by 10 is 3. So I have to pick a value for T that makes this fraction also equal 3. So if I make T a 5, then 15 divided by 5 is 3. So that equation works. Well, now let's put 30 in for S here, and let's put 5 in for T over here and see, does it really equal 3 over 2? Does this one work? Well, 30 divided by 5 is 6, and 6 does not equal 3 over 2. So that's a false. So you can pick numbers, but the thing is they have to work. So like if I picked 30 for S, 30 divided by 10 is 3. So I better make sure that whatever I put in for T, that makes this fraction 3. So I had to put a 5 in for T. But I could have picked different values than that. I just decided on those. Okay, we're going to fill in the blanks here. All right, well, I'm noticing, a lot like this top problem, I'm noticing that the X and Y were horizontal, now they're vertical. So then that means the 6 and the 34 should go vertical. So this should be a 6 and this should be a 34. And I guess the question now is, does that reduce at all? So let's see. If I divided the top by 2, I would get a 3. And if I divide 34 by 2, I'd get 17. So it reduces down to 3 over 17. Okay, next page. So you might be given a kind of a problem where you're given a real thing and then like a scale model. So up here it says that the real Titanic itself was 882.75 feet long. And then it was 92.5 feet wide. Now, obviously the Titanic wasn't a rectangle, but I'm just using this for length and this for width, just to help visualize. And then over here it says that the scale model was 107 feet long. And now I got to be careful. I got to put things in the right spot. It was 882.75 feet long. And now the model is 107.5 inches long. So if that was on the bottom, I better put it on the bottom of this one too. So this is 107.5 inches long for the model. And it says, how wide should it be? I don't know. That's what we have to find. So we need to set up a proportion. And we can do this a couple different ways. We could do length divided by width. Now we just have to stay consistent. So if I do the real Titanic length divided by width, then I'm going to do the scale model length divided by width. So this is the real Titanic, and this is the model. And we stayed consistent by doing length on the top and width on the bottom. Okay, so now we need to solve this. So we're going to use cross multiplying from yesterday. So we're going to do 882.75 times x equals, and then we're going to multiply those two together. 107.5 times 92.5. So we're going to need to type in our calculator. What is 107.5 times 92.5? And that ends up being 9,943.75. And we need to get x alone. So now we're going to have to divide by 882.75. And then what's x? X equals, put that in your calculator, divide those out, and you get 11.26. And we were talking about, well, I should have labeled these. These were feet. That was the real Titanic. And the model was inches. So we just solved for the width. So this should be 11.26 inches. Always be really careful about what the units are. Okay. Next problem. I only have a few minutes left, so there might be a second video. Just wait and we'll see how we're doing. Okay, so this problem, they're giving you the ratio, so all we have to do is look at the picture and fill in these pieces. So QU, I don't know how long that is because I don't know how long SU is. So if I don't know how long it is, I'm just going to leave it as QU. QS is 6. RV, the whole thing. That would be 4 plus 6. So RV is 10. RT is 4. Okay, now we're going to cross multiply to solve it. So QU times 4 will equal 10 times 6. So QU times 4 is going to equal 60. And then we have to divide by 4 to get QU alone. So QU will equal 60 divided by 4, which is 15. But it's asking for us to find SU. So we just learned that QU, this whole thing, was 15. But I want SU, which is right here. So I'm going to have to do 15 minus 6. Okay, QU would equal QS plus SU. I know that QU is